Hi, this is Grover with Blue Collar Codes, Quick and Dirty, episode 26. Gonna go over recursion in the form of tree traversals. Episode 26.py can be found in the GitHub repository linked in the video summary. So to start off, the image I have here is a balanced binary tree, and it is going to be the example tree that I'm going to traverse using these recursive methods. Now, I prefer using class node structure simply because it resonates more with me, and creation of nodes and then links with left and right for these solid lines. It kind of creates a visual representation, much more so in my mind than, say, implementing a tree structure with an array or a Python list as its core collection. So that being said, I started off and created this directly without trying to use a base class or a tree class. And I would recommend doing this if you're entirely unfamiliar with binary trees or any tree structure, simply because it kind of makes things very tangible. And when you start traversing them, you can easily change a value and or remove a link to see what would happen, or change references or what have you. It's much easier in this way to alter how you're going to traverse a tree, test out new things when you have it all laid out like this. At least it makes it much more explicit versus implicit. So there are different ways of traversing a tree structure. All of these are depth first, but the main core difference is where it is checking for your value. So all of these are basically, you're giving it a starting node, like the root node, and then you're giving it a value to search for. And for all of these, it's basically going to be searching the left side first all the way down, and then when it no longer finds anything, it's going to start searching the right at each level. And the main difference between pre-order, in-order, or post-order traversal is where it is checking for the value. So in pre-order, before it's going to traverse down the left edge or right node, it is going to check for the value. And then here it's checking in between. So in order, it's checking in between each recursive function call or method call, and then here in post it is just checking for the value at the end. Now, a discussion of how recursive methods works is much easier to just go through an example, but to kind of give you a bit of an idea as food for thought before we go over it, you essentially are creating a method or a function that is calling itself in part of said function. So exactly as you have it here, and what is required is that in most of these recursive structures, there needs to be a way for it to end, either by finding the value that you're looking for, if it is somehow searching a value, or returning a calculation, what have you. There needs to be some endpoint, and it needs to be located correctly in order for you to get the desired result and for it not to error out. So for example here, traversing the tree structure, we're basically just traversing along these edges and these attributes that are connecting all the nodes together. So it's going to travel to the left when it's called here on the current node's left child, and then it's going to start back from the stop using that as now the node, the current node, and then it's going to traverse here again and travel down the left and call itself. The important thing to know is that it is going to, at some point, find one of these return statements, and then it's going to return or exit the current function call, or method call in this case, and then it's going to return to the last place or where it was called, and then it's going to have to run through the rest of the iterations. And it doesn't make sense right now, but let's just dive in and go through an example with the Python debugger. So I made it a breakpoint here when it's checking the value. And again, I recreated this structure on the left with nodes by hand, if you will. So let's dive into the debugger. And so right off the bat, I would keep an eye on as I step through these is you can tell where we are as far as which level of the stack and which node is the current node. That is the node that is going to be listed here in the upper left. So that is essentially where we are, what current call we're in. And why it's called a call stack is that as it keeps on calling, it's adding another call on top of it, another call on top of the next stack, as you'll see, and it has to perform or find a return statement to exit the call that's on the top of the stack, or to pop the topmost function call so that it can now return to the next one in line and then complete the whole cycle here, as you'll see momentarily. So again, we're on node 1, and we'll see it's going to print the value. It printed out the value here. Now it's going to make another call, and as you can see, it added that stack. And now our current node is node 2. That's where we're currently located in the call stack. And so we'll step through it because none of these values equal 12. By the way, we're looking for the value 12 here, and we're just going to go through it, and you'll see how these function calls stack up. And so now we're currently at the 4 node because it's traversing down by continually calling the node left. You know, it's making this function call and just placing the node to its left, the child node. And it's going to continue until it finds none. And that's the important part here that I wanted to get to, in that we needed to put this none in here to catch this case so it would actually stop without throwing an error and trying to say go to the left of a none node, which obviously doesn't exist because none is not a instance of our node class. And so we needed this here to stop that traversal. And the important thing to note now is what happens when we now exit. So this return is going to exit the current call that is on none. So, and it's the 5th layer. So you have, this was the 1st, 2nd, 3rd, 4th, and the 5th. It would be right here. You know, this is the left node. So it's going to exit at this current point, right? And that's the thing to kind of remember as you're trying to make your own recursive functions, is it's going to go back to the point where it just executed until it finds a return statement. Or in this case, it might, it'll call the right side now. So this would be if it actually returned a valid response. So let's say it found it, and instead it's returning the node, it'll return the value and propagate that value all the way back out of all of the recursive calls for that method. But in this case, it's none, so it passes over that, and now it's going to try to see if the value is on the right node. But again, 8 doesn't have any right child, so it's going to just stop right there, return, exit again. Now we're back on 8th node, and then we're going to find ourselves at this return statement, which then exits out of the next level here. And now we find ourselves back at the node 4 function call right outside of or after the left function call. So now it's going to do the same thing. It's going to now look at the node 9 and add that to the stack. And so now we're checking node 9, and then it's going to check the left and then the right again here. It's not going to find anything. It's going to hit that last return and then exit out of that, and we're going to find ourselves back at node 4. But now we're finding ourselves at the function call when we had node 4 as the argument. It's going to return us here because it just checked the right child of node 9, and it's going to exit out and then jump up one more level again. So now we're going to find ourselves at node 2, and now it's going to travel to the right and then the left, and then left and right again, go back up, go back down, left and right again. And so this was just an overview of recursive methods for traversing tree-like structures. And just to review again, things of note, things to think about is there needs to be a base case where essentially you can't just have it open-ended if you want to actually have your values found and returned without creating any errors. So you need to think of these base cases, like where is it going to end the recursion? And when it comes out of this function call, where is it going to return the values that you want to find if you're doing a search or a calculation or what have you? And definitely recommend using breakpoints and the debugger functionality here, just because it gives you a nice easy way to view what the code is actually doing through all of your iterations. Again, this is Grover, Blue Collar Codes, the quick and dirty. Thanks for joining.